On the approach, our feet guide us toward the edge. We anticipate the future, the focus, and the fear. We need no attention in this moment, as our feet effortlessly take us forward, unaware of the complex systems responsible for keeping us upright and in balance. We are too busy planning ahead for the moment in which we will really put our innate balance system to the test. Leaving solid ground, the slackliner steps out onto the rope. Somehow, even without the earth beneath his feet, he continues to balance. How is it possible? Beyond the thousands or 10,000s of hours of practice, an invisible network of complex feedback loops enables him to accomplish this incredible feat. Outside of extreme situations such as this one, the only time we fully appreciate the beauty and difficulty of our balance system are the days in which we, like every other land mammal on the planet, take our first steps. For the first time, we feel the opposition of our muscles and gravity. We teeter and fall, but we continue to try until we are able to walk forward, away from our mother's hands and into the world. From that point on, our balance becomes second nature, and it is incredible what we can accomplish.
If I had to kind of title myself, I would say that when you start to learn different skills and the equation of how things work, whether it be climbing or slacklining or base jumping or whatever, after you see what you can do, it's hard to unsee that.
What is left out of this athlete's description of his accomplishment is the network of systems working on his behalf. If you look at a slackline, it appears quite simple, where the athlete simply needs to get from point A to point B. But negative feedback, which can be diagrammed as a circular loop, is the essence of balance. Input informs output. This brings me to one of the reasons why balancing is so exciting. It's an outward expression of the negative feedback systems that already take place inside the body to maintain homeostasis.
While each of the input, output, and control parts of the system are crucial, this video focuses on the inputs. The inputs to the balance system are incredibly complex and interesting. Input comes in three categories. 1. Input from the proprioceptive sense. 2. Visual input. And 3. Vestibular system input. Let's take them one at a time. The proprioceptive sense functions in various ways, but each way has to do with neurons that are triggered by muscle and joint movement. Let's take a look at our slackliner and see if we can identify where the proprioceptive sense is functioning while he's walking. Every time our friend here takes a step, leans one way, moves his hand, or any other slight body movement, proprioceptors are sending signals to the brain and spinal column for processing. If our bodies can control balance with our eyes closed based on proprioceptive senses, when our eyes are open, does our balance improve? You'd probably guess that the answer is yes. Let's look at how this works in a little more detail. Sensors in our eyes, called rods and cones, detect different colors and intensities of incoming light. This incoming light is reflected from all the structures in our surroundings. The input here lets us compare the motion of our head and body to the environment around us and lets us know our position relative to that same environment.
The visual system is joined by the vestibular system that works by engaging a number of reflex pathways that are responsible for making compensatory movements and adjustments in body position. It also engages and sends messages to the brain which contribute to the sense of balance and spatial orientation to coordinate movement. Its main components within the inner ear, the semicircular canals which indicate rotational movements, and the otoliths, which indicate linear accelerations, send signals to the neural structures that control eye movements and keep the athlete upright. While balance everywhere is amazing, slacklining is specifically interesting and exciting because although it depends on successful circular feedback loops, it has a linear component too. Get from one end to the other. Or not.